Hello, this is Play Dynamics Session 1 World of Mechanics. This course is designed for students of age 8 and above. On completion of this course, you will be able to create structures using mechanical beam, demonstrate application of joints and its type, and perform assembly of beams and joints. Now let's break down some concepts. Whether it is a design of a big building or a bridge or even something as small as a chair, everything can be constructed through the science of mechanics. So what is mechanics? Mechanics is the field of science which deals with creating structures that can make our life easier. For example, building bridges to connect two places. Engineers must be well versed with mechanics to build strong and long-lasting structures. So how do we build these structures? To build a house, we require bricks. Bricks are stacked on each other and connected. Similarly, any structure is made by stacking or connecting smaller parts with each other. Just like bricks, our kit comes with beams. Let us understand what is a beam. Beams are straight long bars that are stiff and do not bend. They are used as a basic building blocks. Several beams can be connected with each other to build a bigger structure. So, how do we connect one beam with each other? Any structure is built by connecting smaller structures together. These smaller structures are connected using pegs. Play Dynamics kit comes with two types of pegs: friction pegs, frictionless pegs. Friction pegs are used to connect one part with another in such a way so that both parts do not move. They create fixed joints. Frictionless pegs are used to connect one part with another in such a way that both parts can move freely. They create moving joints. Here, there are two beams. Beam 1 and beam 2 are connected using a peg. If we use a friction peg, that beam won't move. But if we are using a frictionless peg, that beams can be moved. We have learned about beams, we have learned about joints, and we have learned about types of pegs. Now that we understood the concept, let's go into the task for the day. Here we will be creating a triangular structure using beams and joints. And for that we will be needing supplies. We will be needing two beams of size 13, one beam of size 11, two beams of size 9, one beam of size 7, frictional pegs in 6 numbers, and 6 frictionless pegs. Like every engineer, let us begin by creating a design of what we want to build. Draw the shape of a triangle that can be made using the beam and pegs on the design sheet provided to you. Once our design is ready, we can start making our first shape. Let me ask you one thing. Which peg should we use? And why do we need to use that particular peg? Before we begin to construct the structures as mentioned, a plan is necessary. Engineers call this plan as design. A design is a well thought out drawing of a build or structure. It gives us idea about any forthcoming challenges related to material or designing. One basic structure that can be built using beams and pegs is a triangle. Now that we are ready with our design, select the supplies required to start constructing a triangle using beams and pegs. So why wait? Let us start our assembly. Hi there. Today we are here to learn a little bit about the fundamentals of mechanics. So with us today we have some beams and few blocks. So at first let me tell you what a beam is. So beams are some rigid elements that we use to build structures. Now let me show you how we build structures using these beams. So for example, if we have to attach these two beams, then we will be using something like this that we call as pegs. Here we have two types of pegs. One is frictionless peg, one is friction peg. So we will be attaching these non-frictional pegs to attach two beams or two other objects. Well, if we don't need any kind of movement there, we will be using frictional pegs so that our structure is stable. And in other cases, we can use the non-frictional pegs. So to start off with, let us build some structures using these beams and pegs. So at first, we will be using 3 beams to build a triangle. Let me also tell you that we have beams of different sizes. You can count the size of the beam by counting the holes that are present in the beams. So for example, the size of this beam is 1, 2, 3, 4, 5, 6, 7. So this is a size 7 beam. So we will be using one 7 size beam and 2 12 size beam to make a triangle. So at first, we will be using one peg, a non-frictional peg, and then we will use another non-frictional peg to attach the 7 sized beam, that is size 7 beam. And then we will connect this whole structure to make it look like a triangle. So the blocks that we have also, can see these are some of the connections of beams that are already made and rigid. We have learnt upon different mechanical components. We have learnt about interconnecting beams and pegs together. We also learnt about building a triangle using beams and pegs. We have now learnt about beams, types of joints, and constructing simple structures using them. But the learning doesn't stop here. Learn more by solving a challenge statement ahead. For the challenge task, we will be creating a stable rectangle shape using beams and joints. For that, first create a design on design sheet provider and ensure that rectangle built is highly stable. Use a beam of size 11 in diagonal to restrict the rectangle shape from deforming. Next, we will be making a rectangle out of this. So at first, we will take 2 beams. We will use 4 non-frictional pegs, and then we will use the size 9 beam, and we will connect all the 4 beams together so that it looks like a rectangle. So now here our rectangle is ready, but we can see that there is a certain movement happening in this rectangle. So in order to avoid that, we will be using another beam so that the movement is avoided. So we will stick this beam behind the rectangle using 2 more pegs. So now our rectangle is properly rigid and there is no movement happening. Learn more about different types of beams and their uses by visiting the link mentioned below. Try building structures, use different types of beams, keep tinkering. Until next time, bye.